Welcome back, guys. My name is DrAvitech and you're welcome to my YouTube channel. If you've not hit the subscribe button, please do so, as every single video that I'm going to upload here would be of benefit to you. So today, I want to talk about coordinate geometry for JAMB students. So every single question we are going to be doing is going to concern JAMB and YX students, and it's very, very detailed. So this video is going to be a long one, but it's going to explain every single thing you need in coordinate geometry. So here's what we're going to do. First of all, every single one of us have drawn graphs before. So we kind of know that there's something called the X. So we kind of know that there's something like this. We know that, oh, we have our X-axis, we have our Y-axis. So this is not difficult. So we have our X. Let me say this is Y. No, it has to be Y. And this is X. In real sense, we're supposed to actually say this is our X coordinates, and these are Y coordinates. Now, coordinate geometry is very, very important. I don't know if you've actually watched some movies where they'll say what's your coordinates or what's your location, and then they give it in form of a coordinate. So it's very, very important. Now, the first thing you want to know is this. Coordinate geometry is the study of straight lines. It is the study of straight lines. Now, for the sake of this very video, I'm only going to be calling this just coordinate geometry. Some textbooks will call it the straight line, some will call it analytic geometry, but it's all the same. So let us talk about straight lines. Before we find a straight line, we need a point at least. So let us find a point. I'm not saying a point forms a straight line. I'm saying, let me explain what a point is. Let me put this here. Now, a point is actually a location on any particular plane. So this can be seen as the Cartesian plane or the rectangular Cartesian plane. So it's a position on the plane. Now remember, when you were drawing graph, you go and find, oh, where is S at 4, Y at this? You now come here and mark a spot, and you say X marks the spot. So that's actually what this is all about. But that's just a point. So this very point here, before you draw a point, do you know that you need the value of X and you need the value of Y? Do you remember? You need the value of X and you need the value of Y to get a point. So this means that every point must have X and Y. So it's always in an ordered pair. It's always in an ordered pair. It is ordered because X always comes first, the Y comes later. So it's always in an ordered pair. It's a must, always an ordered pair. Now, does this point form a line? No. The point is just a location. So how do we form a line? We need 2 points. So let me say there's another point here. This point here is also having X, Y. It must always be X, Y. So these 2 points will now come together to form a line. And here we have a line. So let me say this is line AB. So that's a line AB. Now, what do we then study? This very line you see here is going to be having different properties or characteristics, because a line we need some information on this very line. How steep is the line? How long is the line? What is the middle of the line? What is the y-intercept of this very line? Because it's going to pass the y-axis. What is also the angle of slope? What angle does it make with our x-axis? You know, so many things are going to be our question. Now, the first thing we're going to be talking about is gradient of a line. Now, what is gradient of a line? Take note, another name for gradient of a line is slope. Another name for gradient of a line is slope. So, slope or gradient is the tendency to fall when climbing a line. Please take note, by textbook definition, gradient measures the steepness of a line. The steepness of a line. So what does steepness of a line mean? It measures the tendency to fall. That is what it does. The tendency to fall. So let me not talk about this kind of line now. Let me discuss 2 important lines. First of all, so this is a line. Let me say this is a line AB. Now, is this line horizontal or vertical? The line is going to be horizontal. So this is a horizontal line. Imagine if this is me. So I want to move from this point down to this very point. What is the tendency for me to fall when walking on this line? What is the tendency? Can I actually fall? Do you think it's possible? For me, I think it's not possible. That is to say, there's no stone on the floor, there's no village people, there's no juju or whatever. I'm not going to fall. Because think of it, I've been walking on this line ever since. I've been walking on the ground ever since, and I've not fallen. Because the ground is horizontal. The ground is a horizontal line. So I can't fall. And basically, people walk around the horizontal ground and they barely fall, provided every other thing is constant. There's no stone on the floor, there's no water, and all of the rest. So the tendency for me to fall there is 0. Take note that the symbol for gradient is m. The symbol for gradient is what? M. That's the symbol for m. Or that's the symbol for gradient. Now this is a horizontal line. So the gradient of every horizontal line is 0. Now how about the gradient of a vertical line? So let me draw a vertical line. So this is AB. That's the gradient of, that's the vertical line. Now, from this point to this point, imagine if this is me. Imagine, because it cannot be me. So imagine if this is me, and I want to move from this point down to this very point. The both of us, we know that this is not possible. Because a vertical line is like a wall. Your wall is always vertical. So we have vertical wall, horizontal ground. So the vertical wall, you cannot climb it. That is why if you notice, whenever they want to climb a wall, they always use a ladder. Because you cannot climb a wall using just your legs. You will fall on the ground. It's not possible. It's not possible. You must always use a ladder. So what is the gradient here? Thinking of it, would I fall? Yes, I will fall. I'm not Spider-Man. I'm not a superhero. We're not doing film trick here. I will definitely fall. Because imagine me now, I want to climb this one. Let me say I put my back on the floor and I want to climb. I'm going to fall. It's not possible. You're not a lizard. You're not a reptile. You can't do that. So the gradient here, can I say that the gradient here is 1? I can't even say that. Can I say the gradient is 2? I can't even say that. Can I even say it's 2,000? I can't say that because this is this is a measure. It's a measure. And the way I'm going to fall, the magnitude of my fall will be so big, so large that my head will scatter because I'm going to fall on the ground. Even if for some reason they give me a suction kit and I can be able to clip on the wall, or I have claws on my fingernails like Spider-Man, and at that point I now lose those very grip and I fall on the ground, my head will just scatter. So can I even say it's 2,000? No, I can't even say it's even 2 million. So what is then the gradient of a vertical line? It is always undefined. Because you cannot define how much you will fall. The number is so big that you can't define it. It is very, very large. Most people want to say that it's infinity. Please refrain from using that. You can say it approaches infinity, but it's just undefined. So in this case, we're going to just be using. So in this case, we're just going to be using undefined. That's what we're just going to be using, just undefined. Now, this is for a vertical line. This is for a horizontal line. Now, what if the line is neither horizontal nor vertical? What do we then do? Please take note that gradient is a function of two things. It is a function of rise and run. Now, take note, anytime you take a movement, anytime you take a leap, two things are going to change. You are either going up or you are going horizontally. When you are going up, it is how much you've risen. So, rise is a function of the y-axis. Rise is a function of the y-axis. Then run is a function of the x-axis. So, taking a look at this very line, whether I like it or not, if I want to move from this point to this point, if you notice, I did not only go up. No, I did not only go up. I also moved towards this very direction. So, there's going to be a run. There's also going to be what? A rise. So, let me just see. Let me trace this point like this with broken lines. Then this guy like this. So whether I like it or not, there's going to be how much I've run from here to here. There's always going to be this guy. So this is my run. Oh, sorry. This is rise. I'm going up. So this is rise. Then if I'm going this direction, this is my run. Now, gradient is rise over run. Gradient is rise over run, because rise is the change in your y. Remember I said rise is a function of y. So change in y is the rise. Then what is run? Run is the change in the x. How much you've risen divided by how much you've run. Not like you look like you are running, but that's just it. So the formula for gradient is delta y. Remember, I have two values here. So I'll say this is x1, y1, this s2, y2. So what is the change in y? I have y2, I have y1. So how much have I changed? It's going to become y2 minus y1 because delta y means change in y. Then delta x means change in x. So for x, this becomes x2 minus x1. And this right here is the formula for the gradient of any line, even if it's horizontal, vertical, whatever. This becomes the formula for the gradient. So with this, let us get started. Let us start solving the problems. Remember, hit the subscribe button, like this very video, and share it across to all of your friends. Let us proceed. So, this question 1, it says a straight line passes through the points P brackets 1, 2 and Q brackets 5, 8. Calculate the gradient of the line PQ. So first of all, remember that gradient M is y2 minus y1 over x2 minus x1. That's the formula for gradient. So let us name our points. So this is x1, y1. This is s2, y2. So y2 is equal to 8. Y2 is equal to 8 minus y1 is equal to 2 divided by x2 is 5 minus x1 is 1. So that's what we have. Now what is 8 minus 2? 8 minus 2 is 6. Now what is 5 minus 1? 5 minus 1 is 4. So let us now divide because you can see that 2 is common here. So if you reduce this by dividing by 2, 6 over 2 is 3, 4 over 2 is 2. So the answer for that becomes 3 over 2. So that's C. So that's how you solve for that. Let us take a look at the next question, number 2. So here's question number 2. It says, find the gradient of the line joining the points 2, minus 3 and 2, 5. So this is what we have. Now, what do we do? It's actually easy. We go again by the formula. M is equal y2 minus y1 over x2 minus x1. So let us name our points. Every point must have x and y, x and y. Since this is the first point, I'll say this x1, y1, this s2, y2. So what's y2? Y2 is equal to 5. So this is 5 minus what is y1? Y1 is equal to minus 3 divided by what is x2? X2 is 2 minus what is x1? X1 is 2. So this is 5 minus minus is plus divided by 2 minus 2. So what is 5 plus 3? That's 8. And what is 2 minus 2? That's 0. Now here's the problem. What is 8 over 0? What came to your mind when you saw 8 over 0? Would it be 0? Would it be 8? What do you think? The answer of this is undefined. You cannot divide by 0. Later on, I'm going to make a short video on why minus divided by 0 is undefined. So the answer to this is undefined. Take note, any rational expression by the denominator, anytime your denominator is always having 0, it means it is an undefined expression. That's the meaning. Let us take a look at the next question. Number 3. Here's question number 3. It says, the gradient of a line joining s, 4 and 1, 2 is 1 over 2. Find the value of x. So this is a JAMB question from 2014, number 33. It says we should find the value of s. They've already helped us to solve the gradient. So remember that gradient m is equal y2 minus y1 over x2 minus x1. So the gradient has been solved for already, and it is 1 over 2. So I can replace the m here with 1 over 2 because they've already solved for it. Then let me name my points. I think let me just write my points here. S, 4, and then 1, 2. So this is x1, y1. This is s2, y2. So y2 is equal to 2. So this is 2 minus y1 is 4. Divided by x2 is 1. Minus x1 is x. Let us continue. So this will become 1 over 2 equal, what is 2 minus 4? 2 minus 4 will give us minus 2. This is minus 2 divided by 1 minus x. At this point, we cross multiply. So you're going to say this with times this. So that's 1 bracket 1 minus x equal 2 with times this. So that's 2 bracket minus 2. Now 1 times anything is that same thing. So this is 1 minus x. Then 2 times minus 2 is minus 4. Now, I'm trying to make x stand alone. So I need the 1 to go to the other side. So this is minus x equal minus 4. If this one goes well, it's going to become minus 1. So this is minus s equal minus 4 minus 1 is minus 5. Now, both sides have minuses. Both sides have minuses. So this will be x equal to 5 because the 2 minuses will go away. So that's how to solve for that very problem. The next one. This next question says, what is the value of p if the gradient of a line joining minus 1, p and p, 4 is 2/3? That is 2 over 3. This question is from JAMB 2009, number 32. Back then, before CBT came into place, you can actually tell what question is going to be on what number. If you notice, back then in the days, coordinate geometry is always around question 32 to question 34. It's always within that number. So there used to be a time where JAMB was like that. You could tell what question is going to be on a particular year. So not really what exact question, but what exact topic is going to be on a particular year. But now, everything does scatter just like the country. So let's continue. So what do we do? Remember, this is x1, y1. This is s2, y2. Now, let us go by saying that m is equal y2 minus y1 over x2 minus x1. That's the formula for gradient. Now, they've already solved for the gradient as 2 over 3. So 2 over 3 is equal, what is y2? Y2 is 4 minus what is y1? Y1 is p. Take a look at it. Y2 is 4, y1 is p. So that's what I have. Divided by what is x2? X2 is, where's that guy? P minus x1 is minus 1. So this is 2 over 3. It stays the same way. Then we have 4 minus p. Then this is p minus times minus is plus. So that's what we have. And this is 2 over 3. At this point, I can cross multiply. Let me cross multiply. So 2 with times this. So this is 2 bracket p plus 1 equal to 3 with times this. So that is 3 brackets 4 minus p. At this point, the next thing I'm going to do is to open up the brackets. So 2 times p, that's 2p. 2 times 1, that's 2. Equal 3 times 4 is 12. 3 times minus p is minus 3p. So let's proceed. At this point, you want to make all the p's go to one side. So this is 2p. If minus 3p comes, so it's going to become plus 3p because the sign would always change. Equal to 12. If this plus 2 comes, so it's going to become minus 2. Now, what is 2p plus 3p? That's going to be 5p. Equal, what is 12 minus 2? 12 minus 2 is 10. Now, how would you get the value for p? Divide both sides by 5. So p is equal to 10 over 5, which is equal to 2. So P is equal to 2. We've been able to solve that very problem. Now, the next thing we want to take a look at is midpoint of a line. So, the midpoint of a line, let us talk about what midpoint is. The middle of a line. Let us talk about it. So, as the name suggests, it is the middle of something. It is the middle of something. So, imagine if you have, let us say, 10 and 12, and they say, what number is in between 10 and 12? You clearly know that it's going to be 11. Yeah, 11 is in the middle. But what if I ask you a question and I say, what's the number in between 145 and 355? It's going to take you a bit of a time if you want to just guess it. It's going to take you some time because you want to guess it. However, there's a formula for getting anything in the middle. And what we'll basically do is this. We add up the lower bound and the upper bound and divide it by 2. Or basically what I'm trying to say is, to get this guy in the middle, we say 10 plus 12 over 2. And what is 10 plus 12? That's 22 over 2. So 22 over 2 is what? 11. That's how we get this number in the middle. To get the one in the middle here, we're going to say 145 plus 355. So that should give us 500. Divided by 2, that's 250. So 250 is in the middle. Now, let us come back to equation of a line. So let's say we have an equation here. Or let us say, sorry, midpoint. We have a line here. So this line AB, A is x1, y1. This one is x2, y2. Now we need the middle here, this middle. Take note that this middle is going to also affect x and y. And take note, as the name suggests, midpoint. Midpoint is also a point. So midpoints must always have x and y portion of it. So the midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. This is the formula for midpoint of any line. This is the formula for the midpoint of any line. So with this, let us solve questions on midpoint of a line. So here's the first question, and it says we should find the midpoint of the line ST. So the coordinate of S is passing through minus 5, 4, and coordinate of T is at minus 3, minus 2. So remember, according to the formula, midpoint is x2, okay, let me start with x1. x1 plus x2 over 2, y1 plus y2 over 2. That's the formula for midpoint. So let us name our points. This will be x1, y1, while this is x2, y2. So what is x1? x1 is minus 5. So this is minus 5 plus what is x1? Sorry, what is x2? x2 is minus 3. And this will be over 2. Then what is y1? y1 is 4 plus what is y2? y2 is minus 2 over 2. Now this will become minus 5 plus times minus is minus. Then you put your 3 over 2. And then this is 4 plus times minus again is minus. Then you put your over 2. Now what is minus 5 minus 3? Minus 5 minus 3 is minus 8 over 2. Now what is 4 minus 2? That's 2 over 2. Now let's cancel out. Let's cancel out. So this is minus 8 over 2 is 4. 2 over 2 is 1. So the answer is C. That's the answer to that very question. Let's take a look at the next one, number 6. Question 6. The midpoint of P, which is at x, y, and Q, which is at 8, 6, is 5, 8. We have to find the value of x and y. So this is x and y. Now, this very question, they've helped you to find the gradient. I say gradient. They've helped you to find the midpoint. They've helped you to find the midpoint. So what do you do if you're asked to find x and y? So that's easy to do. The first thing you want to do is you want to write out your midpoint formula. There are two ways of solving this. I prefer the second one, but let me do the first one. So the midpoint is x1 plus x2 over 2, y1 plus y2 over 2. So the midpoint has been given to us as 5, 8. Then the 2 points we have, these 2 points we have. This guy right here, let me name them. So this is x1, y1. This is s2, y2. So x1 is x plus x2 is 8 divided by 2. Then y1 is y plus y2 is 6 over 2. Now, there's really nothing we can do further apart from compare them together. 5 here is the first one here before the comma. The first thing here before the comma is x plus 8 over 2. So we can compare them together. So compare. So by comparing, we can say 5 is equal x plus 8 over 2. Then after this comma, we have 8. So 8 is equal, which is the second term. So what's the second term here? Y plus 6 over 2. Are basically comparing both of them together. Now let us solve each part. I can put an over 1 here, then I cross multiply. 1 times anything is that same thing. So this is s plus 8. Then 5 times 2 is 10. Now this is x. If I take the plus 8 over to the other side, it becomes 10 minus 8 because the plus will change to a minus. So this is x equal 10 minus 8 is 2. So that's for that part. Now on this side, I can put over 1 here. 1 times everything here will still give me that same thing. So that's y plus 6 equal to 2 times 8 or 8 times 2 is 16. So I need to move the plus 6 to the other side. So this is y equals 16. If the plus 6 goes over, it becomes minus 6. So this is y equals 16 minus 6 is 10. Now remember, the way it was put, x is first before y. So this is 2, 10. So the answer to this question is A. That's how you solve for this very problem. However, I have a better way of solving it. And let's see if you can get it done. Look, so I have a line here. The line is PQ. So P is S, Y. Then Q is 8, 6. The middle is 5, 8. Now here's what I'll do. They told us that they divided something into 2 equal parts. That's the middle. Into 2 equal parts. And they got 5, 8. So the first thing I want to do is to get the full length. The full length means I have to times by 2. So if you times by 2, 5 times 2 is 10. Sorry. This guy has been disturbing me. So that's 10. Then 8 times 2 gives me 16. So that's what I'm going to have. Next, what I'm going to do next is to say this minus this to get this very one. Let me say that again. After getting the length of the full guy from the midpoint, after timesing it by 2, if one side is already 8, 16, to get this other one, you just say this minus this. So what is 10 minus 8? That's 2. Then what is 16 minus 6? That's 10. So you can see that the answer is 2, 10. Let us take a look at another problem like this and see if you understand it. So question number 7. Here's the next question. It says if the midpoint of the line PQ is 2, 3 and the point P is minus 2, 1, you have to find the coordinate of the point Q. I want to solve this question with this short cut or this short form that I've used. So with this short form that I've used, that's what I want to do. Now, what I'm going to do is very, very simple. It's very, very simple. So instead, let me draw the line PQ. So this is Q and this is P. Now, if this is the line PQ, we're told that the midpoint, the midpoint of the line PQ is 2, 3. Then the point P is minus 2, 1. We're asked to find the point Q. So this one is unknown. Here's what I'm going to do. Remember I said they've taken the half of something to get this. So to get the full one is to times it by 2. When you times it by 2, 2 times 2 is 4. 6 times 2 is 6. Sorry, 3 times 2 is 6. Now the next thing is this. I'm going to subtract. I'm going to say this minus this. Remember, it was what I did here. I said this one minus this one. So you now say 4 minus this. So what is 4 minus 2? 4 minus minus 2. 2 minuses make up a plus. So 4 plus 2 is 6. So this is 6. Next, this is 6. 6 minus 1 is going to be what? 5. So the answer is just B, 6, 5. That's what the answer becomes. And it's easy to solve. And on your own, you can decide to follow this same approach to solve the problem. It's still going to be correct. So all you have to do is just say, let the point Q become X, Y. Then you can still get your answer. Let's take a look at the next one, question number 8. Here's the next question. We asked to calculate the midpoint of a line segment y minus 4x plus 3, which lies between the x-axis and the y-axis. It is a jamb question. Now, to start with, this very problem looks a little bit different from this, but let us get it to where we can solve it. Whenever you are given an equation, you can see that this line, its told to lie between the x-axis and the y-axis. So what this means is, let me see, that's a positive gradient. So I kind of have a line that is between these two axes. So here's what I'm going to do. I'm going to find the x and y intercept. I'm going to find the x and the y intercept. That is what I'm going to do. I'm going to find the x and the y intercept. So the line kind of looks like this. It lies between this and this. Lies between this and this. Or maybe here. It lies between the two. Depends on, let me see, what's the y intercept? Minus 3. Okay, so this is the perfect representation of the line. It kind of looks like this. Yeah. So this is not it. So what we have to find is this point and then this very point. So we need to find the x and y intercept. Now, that's easy to find. So the first thing we have to do is to say, let s equal to 0. Because if we say s should be 0, we're going to find the value of y. So that becomes our y intercept. So let s equal to 0. So we have y minus 4x plus 3 equal to 0. So this is y minus 4 brackets. X is now 0 plus 3 equal to 0. So this is y minus 4 times 0 is 0 plus 3 equal to 0. So this is y equal to, if this plus 3 goes over, it becomes minus 3. So we've been able to get a point because s is 0 when y is minus 3. So this is 0, minus 3. X and y. We've been able to get a coordinate, a point. The next thing we're going to do is to say let y become 0. Since we've said let s become 0, y should be the one that's going to become 0 next. So let y become 0. So what we're going to do next is we have our equation y minus 4x plus 3 equal to 0. So this is y, which is now 0, minus 4x plus 3 equal to 0. 0 is nothing. So this minus 4x, if this plus 3 goes away, it becomes minus 3. Now to get the value of x, divide both sides by minus 4. So x is equal minus 3 over minus 4. So if the minus should cancel out, we just have 3 over 4. So that's the value for x. Now this is also another point. You start with the x. S is 3 over 4. So this is 3 over 4, what's the value for y? 0. So that's a point. That's beautiful. So now we have this and we have this. So this is also x and y. So we can say this is x1, y1. This is s2, y2. That's beautiful. So midpoint is x1 plus x2 over 2, y1 plus y2 over 2. So what is our x1? x1 is 0. So this is 0 plus what is x2? 3 over 4. Then over 2. Then what is y1? y1 is minus 3 plus what is y2? 0 over 2. So you can see that that's very, very easy. Next, 0 plus 3 over 4 is just 3 over 4 over 2. Minus 3 plus 0 is minus 3, then over 2. Now look at this. This is 3. 3 is divided by 4 and also divided by 2. Altogether, this actually becomes 3 over 4 times 2. That's what it becomes. And then this remains like this, minus 3 over 2. Now this is 3 over 4 times 2 is 8, minus 3 over 2. So looking at this, this is going to leave us with option A. So option A becomes our answer to the problem. So that's A, and that's our answer. Let us move on to the next question. Question number 9. So this right here is question number 9. So this is question number 9. You're asked to solve this. Now, I'm not going to solve this problem because it looks similar to this one. You're asked to find the coordinates of the midpoint of x and y intercept of this line. So it's just similar to this. So what you have to do is you say, let x equal to 0, find the value for y. Then you say, let y be equal to 0, then you find the value for x. So you're going to let me know the answer in the comment section. So you drop your answer, you say number 9, then you pick your option, and then I'm going to reply it. Remember, if at this point you've not yet hit the subscribe button, you're doing something not good. So hit the subscribe button, like this video, and share it to your friends. Let us move on to the next question. Number 10. Now, the next thing I want to talk about in coordinate geometry is the length of a line. That's the next property, length of a line. Now see, remember, we've been treating lines ever since. So a line must have a length. How long is the line? Is it very long? Is it very short? Does it measure 4 meters, 4 cm? What exactly does the length of the line measures? Please take note that length of a line is same thing as distance between 2 points. Now, let us see if we can derive this very formula. It's easy to derive, so do not be afraid. Sorry, so do not be afraid. So we have something like this. Okay, so let me just do it very easy. Let me just make it very easy. Let me just make the line this line. Yeah, this very line. So let me make it easy. Now let me say from here to here is 4, for example. Then here to here is, no, let me make this one 3 since it looks smaller. Let me make this one 4. One has to find the length of this side. Now you can see that the length of this side is going to become Pythagoras theorem, because this is the longest side, which is the hypotenuse. So I'm going to say this is, let me say this is length. So this will become length squared is equal to 3 squared plus 4 squared. So let me make this involve our x and y now. So this very 3, imagine this point was x1, y1, which is our origin. Then this is y2, then this is s2. The difference between these points, we've done this before, this is your rise, this is your rise. The difference between these 2 points is going to be y2 minus y1. The difference between these 2 points is going to become x2 minus x1. Then let me call this one the length. So what would we do? We're going to say the square of the length is equal to the square of this one, y2 minus y1 all squared, plus x2 minus x1 all squared. So this means that the formula for length of a line, to remove this square, we have to square root this very side. So we have to say the square root of y2 minus y1 all squared plus x2 minus x1 all squared. That's what we have. So that's the formula for length of a line. That is the formula for the length of a line. So let us take a look at this very equation. Question 10. A straight line passes through the point, P bracket 1, 2 and Q brackets 5, 8. You're asked to calculate the length PQ. So we have A as 4 root 11, B as 4 root 10, C as 2 root 17, D as 2 root 13. This is a Y equation, however, and it's from 2016, number 25. That's what we have. Now, what do we do? It's easy. Length of a line has a formula. The length of a line is the square root of y2 minus y1 all squared plus x2 minus x1 all squared. So that's the formula for length of a line. So let us name our point. So this is x1, y1. This is x2, y2. So this is the square root of, what is y2? y2 is 8. Take away, what is y1? y1 is 2. And this will be squared plus, what is x2? x2 is 5. So this is 5. Take away, what is x1? x1 is 1. All squared. So that's what we have. Let us continue. So this becomes the square root of 8 minus 2 is 6. So this will be 6 squared plus 5 minus 1 is 4. So that will be 4 squared. Now this becomes 6 squared means 6 times 6, and that's 36. So this is 36 plus 4 squared means 4 times 4, and that's 16. Now if we add these two things together, we're going to be having 52, because 16 plus 36 is 52. Now there's a topic called solve. I'm still going to make a video about it. Now we can simplify this. We can simplify this because 52 has a perfect square in it. At least there's a number that if we take the square root, we know that square root of 52 gives us a repeating, not a repeating decimal. It gives us a decimal that does not end. But however, we can break 52 down. So let's break 52 down. 52 is 4 times 13. Yeah, 52 is 4 times 13. I use 4 times 13 because the square root of 4 has an answer. So let's separate this. This will become square root of 4 times square root of 13. Now what is the square root of 4? Square root of 4 is 2 times 13. So what is 2 times root 13? That will give us 2 root 13. So the answer to this question is D. So that's the answer. The answer becomes D, 2 root 13. Next question, number 11. So here's question 11. If m and n are the points minus 3, 8 and 5, minus 7 respectively, you're asked to find the length of mn. Whenever you see those two straight lines with m and n together, it means the length of mn. So let us calculate. Remember that length is the square root of y2 minus y1 all squared plus x2 minus x1 all squared. That's our formula for length of a line. So this becomes the square root of, let's label our points. So this is x1, y1, while this is x2, y2. So y2 is minus 7. Then y1, oh no, sorry, that's supposed to be a minus. Then y1 is 8. And this will be squared. Then what is x2? x2 is 5. Minus what is x1? x1 is minus 3. You have to be very careful here. So this becomes the square root of minus 7 minus 8 is minus 15, all squared. Then this is 5. Minus times minus is plus, all squared. So this is, let me leave this guy like this, minus 15 all squared plus 5 plus 3 is 8. So this is 8 squared. And this is the square root of minus 15 squared is 225. Any number you square must always give you a positive answer. At least if they are real numbers, you must always give a positive answer. 8 squared is 64. Now when you add this up, 225 plus 64 is 289. So we have the square root of 289. And the square root of 289 is 17. The answer is D, 17 units. You must, the reason they put in units, they don't want to put centimeter, millimeter, so they just put units. So you just understand. So that's number 11. Let's move to number 12. The next question. Question 12. If the distance between the points P, 3 and minus P, 2 is 5, you're asked to find the value of P. So that's what we have. Remember that the formula stays the same. Distance between 2 points and the length of a line has the same formula. So the length of a line, or the distance between 2 points, is y2 minus y1 all squared plus x2 minus x1 all squared. So that's what we have. Now, we've been told that the length of this is 5. The length is 5. So I can write this as 5 equal to the square root of what is y2? Let's name our point. This is x1, y1. This is x2, y2. So y2 is just 2. y2 is 2. Minus what is y1? y1 is 3, or squared. Plus what is x2? x2 is minus p. Minus what is x1? x1 is p, or squared. So this is what we have. Now remember that since what we're looking for is inside this square root, we need to remove the square root. So what is the opposite of square root? Opposite of square root is what? Square. So we have to say 5 squared is equal 2 minus 3 squared plus minus p all squared. So that's correct. So this is what we have. Next, let us evaluate our squares, or let's simplify further. So 5 squared is 25, equal 2 minus 3 is minus 1. Then you put your square. Minus p is minus 2p, or square. So that's what we have. So this is 25 equal to minus 1 squared is 1. Minus 1 squared means minus 1 times another minus 1. So that's plus 1. Then minus 2p squared is 4p squared. Because p times p is p squared, 2 times 2 is 2 squared, minus times minus is plus. Now can I move the 1 to the other side? It becomes, yes, it becomes minus. So this is 25 minus 1 equal to 4p squared. 25 minus 1 is 24 equal to 4p squared. Now I have to divide both sides by 4. So let's divide by 4. So divide by 4. So this is 24 over 4 equal 4p squared over 4. So this will cancel this. 24 over 4 is 6. So 6 is equal to p squared. What is the opposite of square? That's square root. So this will be the square root of 6 is equal to p. And that becomes your answer. So that's our answer to this very question. So that's number 12. And it's easy. Let us go to the next one, number 13. Here's the next question. It says, what is the value of r if the distance between the points 4, 2 and 1, arrow is 3 units? So what are we to do? Let us write out our formula for distance first. So remember that distance is the square root of y2 minus y1 all squared plus x2 minus x1 all squared. So the distance is 3 units. So they said it is 3 units. So this is 3 equal to square root. And let us name our points. So this is x1, y1. This is x2, y2. So y2 is letter arrow. y2 is arrow. Take away y1 is 2 all squared. Plus what is x2? x2 is 1. Take away what is x1? x1 is 4 all squared. So that is what we have. What is the next thing that I have to do? This is 3 equal to the square root of arrow minus 2. Leave it like that. So this is arrow minus 2 squared plus what is 1 minus 4? 1 minus 4 is minus 3. Then you put your square. The next thing you want to do is to remove this very square root. So to remove square root, you square the other side. So this will be 3 squared equal to arrow minus 2 squared plus minus 3 squared. Now what is 3 squared? 3 squared is 9. And then we have arrow minus 2 squared plus minus 3 squared is 9. Remember I've earlier said that if you square any number, you just get a positive answer, provided the number is a real number. This is 9. If plus 9 comes to y, it becomes minus 9. So we then be having arrow minus 2 all squared remaining. Now what is 9 minus 9? That's 0. Equal to arrow minus 2 all squared. Now to remove this very square, I would have to square root 0. So the square root of 0 is equal to arrow minus 2. And we know that the square root of 0 is still 0. So 0 is equal to arrow minus 2. If I bring in the minus 2 to the other side, this becomes 0 plus 2 equal to arrow. And 0 plus 2 is 2 equal to arrow. So So this means the arrow is equal to 2. So B. So that's your answer. So that becomes the answer to that very problem. Let us go to the next question, number 14. Here's question 14. It says, given that M is the midpoint of T, which is at 2, 4, and Q, which is at minus 8, 6, you're asked to find the length of MQ. Now, the first thing you want to do here says, given that M is the midpoint. So let us find the midpoint between this and this. Let us find the midpoint between this and this, first of all. So it is going to be like this. So midpoint is the square root. Oh no, what is the formula for midpoint? That's not it. That's distance. I was trying to think of length. So this question is a combined question. We have midpoint in it, we also have length in it. So midpoint is x1 plus x2 over 2, then y1 plus y2 over 2. So that's midpoint. Next, our points. This is x1, y1. This is s2, y2. So what is x1? x1 is 2. Plus what is x2? x2 is minus 8 divided by 2. What is y1? y1 is 4. Plus what is y2? y2 is 6 over 2. So you put in all of your numbers. Now this becomes 2 plus times minus is minus. And then what is 4 plus 6? That's basically 10 over 2. Now what is 2 minus 8? 2 minus 8 is minus 6. And then we have 10 over 2. Now, finally, you have to simplify this gradually. So minus 6 over 2 is minus 3. Then 10 over 2 is 5. So this is your midpoint. That's M. That's your midpoint. But that's not what the equation says we should find. Find the length MQ. So we're using M and Q. So let me just write them here. So M is at minus 3, 5. Then Q is at minus 8, 6. So here we can now find the length. So the length, formula for length is y2 minus y1 all squared, x2 minus x1 all squared. So let us name our points. x1, y1, s2, y2. So what is y2? y2 is 6. y2 is 6. Take away, what is, oh no, take away, what is y1? y1 is 5. Plus, what is x2? x2 is minus 8. Minus, what is x1? x1 is minus 3. So this is all squared. Oh no, there's another brackets here. Okay. So what I'm going to do next, so say this is the square root of 6 minus 5 squared. Let me leave that one like that. Then this minus 8. Minus times minus is plus. So this is plus 3 squared. So that's what we have. Now this becomes the square root of 6 take away 5. That's 1. So this is 1 squared. Minus 8 plus 3 is minus 5 squared. So what would I do next? 1 squared means 1 times 1. So that's basically 1. Minus 5 squared is 25. Remember, if a number has minus and you square it, it's going to be positive. The minus goes away. 1 plus 25 is 26. So the answer to this question is 26 units. And there you have it, A. That's the answer to that very problem. That is the answer to that very problem. So that's how we solve that. Let us discuss the equation of a line. There are different ways to write an equation. For lines, there are different ways to write an equation. Now, most commonly, we have the form y equal mx plus c. So this very form, we call it the slope-intercept form, meaning we have the slope and we have the y-intercept. So this is the slope-intercept form. That's the slope-intercept form, which is actually the most common. It is the most common. There are other ways. X over A plus y over B equal to 1. This is just called the intercept form, because A is the x-intercept, B is the y-intercept. But we barely use this. So let us go back to y equal mx plus c. Now remember that I said the symbol for gradient when we started. The symbol for gradient is letter m. So m right here is your slope. It is your gradient. Then c is what? The y-intercept. Every single line must pass the y-axis. It's a must. Every single line you graph, it must always pass the y-axis. It's a must. So looking at this, let us do some simple questions here. Some easy questions. Number 15. Find the slope and y-intercept of the following lines. So A is y equal 3x minus 8. B is y equals 6 minus x. C is y plus 5x minus 3 equal to 0. Then D is 2x minus 3y equal to 6. Then E is 2y plus x minus 3 equal to 0. Then F is 3y plus 4x equal to 5. Okay, some of these guys would be for you actually, because I can't do all of this. Remember, I've asked one question before in midpoint. So I said you should let me know the answer in the comment section. Now, looking at this very problem, it's easy to solve. So the first thing is, the equation of a line is always in this form, y equal mx plus c. So let us write our equation in y equal mx plus c. What do we do? So the first line, mx, what is that thing attached to x here? That thing attached to x. So for A, let me write solution. For A, m is equal to 3. Why is m equal to 3? Why is the gradient equal to 3? Because gradient is that thing attached to what? X. Then what is c, which is the y-intercept? C is what? Minus 8. C is a constant staying on its own. You must always compare this equation to this equation. So if you say y equal mx plus c, you will notice that when you compare, m is equal to 3, then c is equal to minus 8. Be careful because there's a minus. Don't just say c is equal to 8. There's a minus there. So that is it. That's how you compare. B, what is our gradient in this case? Be very careful. Our gradient here, m, this is y equals 6 minus x. So we have y equals 6 minus x. Remember that for your gradients to be found, it is that thing attached to x. It is the coefficient of x. So what is the coefficient of x here? It's minus 1. Even though it's invisible, it is minus 1. So our gradient is minus 1. It's invisible. Then what is c? Our y-intercept is just going to be 6 because that thing that does not have x. C is that thing that does not have x. Remember, they can scatter the equation anyhow. That is why it's like this. They scatter it anywhere, just like Nigeria. Just scatter it. So this is 6. That's what we have. Next, C. C is kind of funny though. We have to do something first before we solve C. So every equation of a line, you must make y the subject before you can find the gradient and y-intercept. So we have y plus 5x minus 3 equal to 0. So what do? We basically move these two guys to the other side. This 5s goes over, minus 3 goes over because we need y to stand alone. So this is y equal, if plus 5s goes over, it becomes minus 5x. Then if minus 3 goes over, it becomes plus 3. I've noticed this. There are times where I'm solving equations and I would say the answer that I've not yet gotten into. Let me put it like this. This is plus 5x. I was going to say it was minus 5x because my brain has already said when it goes over, it's going to become minus 5x. I don't know why it happens. Sometimes I say something that I was supposed to say in the future now. I don't know why, especially when it comes to maths. So does it mean I have power? No, I don't know. So let's proceed. Now, in this very case, what is that thing attached to x here? That thing attached to x is what? Minus 5. So our slope is minus 5. Then what is our y-intercept? Y-intercept is equal to what? 3. Because that's the thing that does not have x. Now, let us go on to the next one. I'm going to leave f for you. That I know for sure. I'm going to leave x for you. Okay, but let me do d. Let me just do d. So d says 2x minus 3y is equal to 6. So what I'm going to do, I want to make y the subject. So I want my y to be positive to start with. I want my y to be positive. So I did minus 3y go over to the other side. So this will become 2x equals 6. If the minus 3y comes out, it becomes plus 3y. Then this is 2x. Now you know that I do not need this 6 to be here. So I need to move the 6 back. And I want to come here. This is minus 6 equal to 3y. We're getting there gradually. So what did I do? In the first case, I moved the minus 3y over. It became plus. So I now have 6 plus 3y. The 6 is done in there, so I move the 6 back here. The 6 now changed to minus 6. For me to make y stand alone, I need to divide every single thing by 3. So divide by 3. Because this is 3y. So this becomes 2x divided by 3 minus 6 divided by 3 equals 3y divided by 3. So this becomes 2/3 of x, 2 over 3x, minus all the 6 over 3. That's 2. Equal to 3, we cancel out 3, so this is y. Now let us compare this to y equal mx plus c. Let us compare it. Now how do we compare? Remember that your slope is that thing attached to x. So what is that thing attached to x here? That thing attached to x is what? 2 over what? 3. It is 2 over 3. So your slope, m, is equal to 2 over what? 3. So that's what we have. Then what is our c, which is the y-intercept? Our c is minus 2. So we've been able to solve this very problem. We've been able to get our slope and y-intercept. Now, basically, JAMB will barely ask you about y-intercept. They don't ask it. Well, the slope is very important because we're going to go into something in the future that requires it. So that's D. Let me do E also. So E is 2y plus x minus 3 equal to 0. This very video is a very, very important and simple video that covers everything in coordinate geometry. So let's make y our subject. So first of all, this is 2y. If this minus 3 goes by, it becomes plus 3. Then if the plus x goes by, it becomes minus x. Remember, you can decide to place it anyhow. You can decide to carry your plus x first, it becomes minus x. Then minus 3 goes by, it becomes plus 3. It's still going to be the same thing. So that's what we have. Next, I want to divide every single thing by 2 so that my y can stand alone. So divide by 2. So this is 2y over 2 equals 3 over 2 minus x over 2. So 2 we cancel out 2. This is y equals 3 over 2 minus, now be very careful here. There's actually an invisible 1 with the x. So this is actually 1 over 2x. It's 1 over 2x. Okay, so what do I do next? What do I do next? I'm going to be saying, where's that guy? Slope m. M is that thing attached to x. So what is that thing attached to x here? That thing attached to x here is minus 1 over 2. The equation of x here is minus 1 over 2. That is the equation of x, minus 1 over 2. And then what is our y-intercept? Our y-intercept is that thing that does not have x. And in this case, it is 3 over 2. That's 3 over 2. So in the comment section, I want you to answer this. It's very simple. What you just do for me is that very equation, put in the number of the equation. Suppose you say number, hold on. That should be number 9. Yeah, number 9. So you say number 9, this is the answer. Number 15F, this is the answer. You know, that way it makes life easy for all of us. And I reply all comments. I don't skip any. I reply all comments. So that's number 15. Let us go to number 16. Now, remember that I started this when I was discussing equation of a line, but I've not yet found an equation of a line. So how do we find the equation of a line? There are two formulas to find the equation of a line, but only one can be used. To find the equation of a line, you need gradient. That is why I said gradient is very, very important. You need gradient, and you need at least 1 point. So this is the first formula to find the equation of a line. Y minus y1 over x minus x1 equal to gradient. So we call this the 1 point form. 1 point because you have just x1, y1. So it is 1 point. 1 point because that's just x1, y1. And the next one is y minus y1 over x minus x1 equal to y2 minus y1 over x2 minus x1. Now these two formulas are basically the same. These formulas are basically the same. But this second one is called the 2 points form because you have your second point, you have your first point. So it's 2 points. Now if you look at these two together, they're actually the same thing. This part is exactly the same with this. But this part that has m, this is the formula for m. Remember, formula for m, formula for gradient is this. This is because there are questions that you'll be solving and the gradient is given to you already. When the gradient is given to you already, you use this very first formula. But if you were not given the gradient, you have to solve for it by putting the formula for gradient. So it's still the same thing. The formulas are the same. So let's take a look at question number 16. Number 16 says, find the equation of the line passing through the points minus 2, 1 and this is tedious, minus 1 over 2, 4. We've got A, y equal 2x plus 3, B, y equal 2x plus 5, C, y equal 3x minus 2, D, y equal 2x plus 1. JAMB 2012, number 34. So this is a JAMB question. I was asked to find the equation of a line. Now in this case, we're given 2 points. So we don't have the gradient. We have to solve for the gradient. So let me solve this problem. Okay. So remember that the formula to solve this is y minus y1 over x minus x1 equal y2 minus y1 over x2 minus x1. So that's the formula to solve for this. So let's label our points. This is x1, y1. This is s2, y2. You have to be very careful because there's a fraction there. But it's not hard. It's easy. Okay, so this is y minus. What is y1? Y1 is 1 over x minus, what is x1? X1 is minus 2. So put in a bracket there. Equal to, what is y2? Y2 is 4. Y2 is 4. Minus y, what is y1? Y1 is just 1. Divided by, what is x2? X2 is minus 1 over 2. This is minus 1 over 2. Then what is y1? Sorry, what is x1? Sorry, x1 is minus 2. So this is minus 2. Remember, the formula has a minus. Then x1 itself is also a minus. So be very careful. Now this is y minus 1 divided by x. Minus times minus is plus. So that's a plus 2. Now 4 minus 1 is 3 divided by minus 1 over 2. Minus times minus is plus. So that's what we have. Next, this becomes very, very... Now most persons might not really know what to do here, but be very careful. And I don't want to go through the rigorous process of addition, taking LCM and stuff like that. So do you know what I'm going to do? What I'm going to do is I'm going to times this place by 2 over 2. In maths, if you multiply by the same thing, because 2 over 2 is 1, and anything times 1 is that same thing. So I'm not changing this expression. The expression is still the same. The reason I'm multiplying by 2 over 2 is so that when these 2 times this very guy, you you will not have a fraction anymore. Because 1 over 2 times 2, 2 we cancel at 2. So you won't have a fraction anymore. So I can do that. So y minus 1 divided by s plus 2 is equal 3 times 2 is 6. Now be very careful. Minus half times 2 is minus 1. And then plus 2 times 2 is 4. I can do this perfectly. As you can see, the fraction, it does disappear. It's gone. So let me say that again. Minus 1 over 2 times 2. Minus 1 over 2 times 2. These two, we cancel this very 2. So be very, very careful. So we then have minus 1. So this is y minus 1 divided by x plus 2 equals 6 over minus 1 plus 4 is just 3. It is the same thing as saying 4 minus 1. 4 minus 1 is just 3. So this is what we have. And this is y minus 1 divided by x plus 2 equal, what is 6 over 3? 6 over 3 is 2. And let me just write 2 over 1 so that I can cross multiply. So this will times this. If this times this, it means I have 1 bracket y minus 1 equal 2 with times this. So that's 2 brackets s plus 2. It works. So 1 times anything is that same thing. So this is y minus 1 equal 2 times x, 2x, 2 times 2 is 4. Now, if you look at the options, y is made the subject in the options. So I want to make y the subject also. So this is y equal 2x plus 4. If the minus 1 comes over, it becomes plus 1. So this is y equal 2x, 4 plus 1 is 5. So that's what we have. So the answer to this problem is B. That's y equal 2x plus 5. So that's what we have. And that's beautiful. Let us take a look at question number 17. Now here's question 17. It says the equation of a line passing through the point 4, 2 and minus 8, minus 2 is 3y equal px plus 9, where p and q are constants. You're asked to find the value of p. So this is a y equation and it's from 2018. This very problem can be solved in 2 ways. Yep. But I think let me not say the hardest way. I think the hardest way to solve this problem is to go and find the equation. Yes, you can decide to find the equation of a line and then you compare your solutions. You can decide to do that, but I don't want to do that. I want to only use gradients to solve this very problem. I want to use just gradients to solve this very problem. So just because it said equation does not mean you have to find equation. So let me use gradient. Now I know that gradient is m, which is y2 minus y1 over x2 minus x1. So what is y2? Let's name our points. So this is x1, y1. This is s2, y2. So y2 is minus 2. So this is minus 2 minus. What is y1? y1 is 2. Divided by what is x2? x2 is minus 8. Then minus what is x1? x1 is 4. Now minus 2 is minus 4. Minus 8 minus 4 is minus 12. If the minus cancel the minus, you can see that 4 is common. So 4 can divide this. So when 4 goes in, you're going to have 1 over 3. Because 4 over 4 is 1. 12 over 4 is 3. So the gradient is actually 1 over 3. Now let's come back to the equation. 3y is equal px plus q. Now what do we do? To find the gradient from any equation, remember that y must be made the subject of the formula. So let's divide every single thing by 3. So 3 we cancel at 3. Y is equal p over 3 x plus q over 3. Now remember I've said something before. That thing attached to x is always a gradient. So m is 1 over 3. Now let us compare this. Sorry, this is not 1 over 3. M is equal p over 3 by comparison. You see, I went ahead in time to go and write 1 over 3. So, from this equation, we've been able to know that our gradient is p over 3. Now, the same line has the gradient as 1 over 3. So, let's compare this. The denominators are the same, over 3 over 3. Then the numerator here is 1, numerator here is p. That tells me that p is equal to 1. By comparison, p is equal to 1. And that's very, very easy to solve. So the answer is what? A. I don't want to find the equation, because if you find the equation, you're still going to compare at the end of the day. So I just prefer this approach. So p is equal to what? 1. Let us solve question 18. Let us solve question 18. Here's question 18. But I feel like I'm going to miss a number somewhere because the number in here, I jumped from 17 down to 19. That was supposed to be 19 because I made a mistake, but that's 18 actually. Now, let us find the equation of this line. What do we do here? It's easy because in this case, we've been given our gradient as 2. Our slope is equal to 2. So it's easy to solve. What do I have to do? I basically just have to say that y minus y1 over x minus x1 is equal to slope. Remember that I gave two formulas of finding gradient. I said you use this one here if you don't have the gradient. Then use this one if you have your gradient. So this is y minus, what is y1? Remember that this is a point. So this is x1, y1. So y1 is 4 divided by x minus, what is x1? x1 is 1. And this will be equal to what? 2. Now, can I say 2 over 1? Yes. Oh, no. I didn't even put the options for this. It's fine. It's still the same thing. So this is y minus 4 divided by x. I can just cross multiply. Oh, God. Let me not use so much time. So let's cross multiply. This with times this. So that's 1 bracket y minus 4 equal 2 with times this. So that's 2 brackets y minus 1. We cross multiply. 1 times anything is that same thing. This is y minus 4. 2 times y, that's 2y. 2 times minus 1 is minus 2. So this is y equal 2y minus 2. If this minus 4 comes first, it's going to become plus 4. So this is y equal 2y minus 2 plus 4 is plus 2. And that becomes the equation of the line. And that was easy to find. So that's how you find the equation of a line just like this. The next question. So here's question 19. Question 19 says the equation of a line which passes through the pair of coordinates 2, 4 and 5, 6 is dash. So what do we do in this case? We don't have the gradient, so we need to use the 2 points form. So this is y minus y1 over x minus x1 equal y2 minus y1 over x2 minus x1. So we're going to use this. So what do? Let's name our points. So this is x1, y1, and this is x2, y2. So this is y minus, what is y1? y1 is 4 divided by x minus, what is x1? x1 is 2 equal to, what is y2? y2 is 6 minus, what is y1? y1 is 4. x2 is what? 5 minus, what is x1? x1 is 2. You can see that I didn't actually stress myself to, be pointing it, but it's still the same. So this is y minus 4 divided by x minus 2 equal 6 minus 4 is 2. 5 minus 2 is 3. So what do we do next? We cross multiply. So this with times this. So we're going to say this is 3 brackets y minus 4 equal 2 with times this. So that's 2 brackets x minus 2. So let us expand. 3 times y, that's 3y. 3 times minus 4, that's minus 12. So we're cross multiplying. Equal 2 times x, that's 2x. 2 times minus 2 is minus 4. We've succeeded in opening the brackets. Now if you look at the options, every single thing here is made equal to 0. To start with, you should know that option C and D is not possible because our y has a 3 in front of it. And in fact, this is the only option that has 3y. So I might as well just say this is the answer. But let's solve to exactly get that value. So this is 3y minus 12. If this 2x comes out, it becomes minus 2x. If the minus 4 comes out, it becomes plus 4. And this will be equal to 0. So this is 3y. Let me put minus 2x. What is minus 12 plus 4? Minus 12 plus 4 is minus 8. And that will be equal to 0. So the answer for that becomes A. So that's how you solve that very problem. And that's just it. Question 20. So let's take a look at the next question. Now, the next thing we would like to look at, because the question 20 is another topic on its own, but it's actually the same topic. So let us talk about angle of slope. Now, over the years, jamb, I don't know what happens. They barely set equation from this, but it doesn't mean you shouldn't learn it. Yeah, it doesn't mean you shouldn't learn it. It's actually very easy. It's actually very easy. So I think the earliest year, what happened? I didn't even write. Okay, it's fine. It's fine. Let's just continue. So it's important because this covers all of coordinate geometry. So you wouldn't be surprised in the whole. So angle of slope. Here's the thing. Your line would always make an angle with your x-axis. It's a must. It must always make an angle with the x-axis. Now, there's even an angle with the y-axis, but I will always consider the x-axis. So the formula is very easy. Tan theta is equal to gradient. That's just it. But this is only when you're talking about one single line. When we're talking about what? One single, this is just a line. Then for two lines, tan theta is equal m2 minus m1 over 1 plus m1 m2. Now please take note, they will never ask you a question concerning the 2 points. So there's no question in this very video that solves anything concerning 2 points. No, I'm not going to be doing this one. I'm just going to be doing any question involving just one line. So tan theta is equal to gradient. And that's easy. It's logic. Tan theta. So let's see equation here. So equation 20 says a straight line makes an angle of 45 degrees on a positive x-axis. You're asked to find the gradient of the line. So let's find the gradient of the line. Remember, I've said that gradient is equal to the tangent of the angle. Look at the gradient is equal to the tangent of the angle. So this is tangent of 45 degrees. And from special angles, tan 45 has a special value of 1. So tan 45 degrees 1, meaning that our gradient is equal to 1. So that's just that very one. So you see, it's very, very simple to understand. So that's for question 20. Let us look for question 21. Here's question 21. What angle does the line root 3y equal x plus 7 make with a positive x-axis? So this time around, we're given an equation. Remember that from an equation, you can get gradients because we know that angle is related to our gradient. So using that equation, you have to find the gradient first of all. So we have root 3y equal x plus 7. For us to find our gradient, we need to make sure that y is standing alone. So for y to stand alone, we need to divide every single thing by root 3. So divide every single thing by root 3. Divide every single thing by root 3. So this goes, y will be left equal. Remember that there's an invisible one here. So this is 1 over root 3x plus 7 over root 3. So that's what we have. Now what will become our gradient? Our gradient here is that thing attached to x, which is 1 over root 3. So that's our gradient. That's what's attached to x. So this is what we have as our slope. Now remember that the tangent of an angle is always equal to gradient. So the tangent of theta is equal to 1 over root 3. So let us think properly. Using special angle, what angle would you take its tan to give you 1 over 3? It's actually 30 degrees. So theta is equal to 30 degrees. This is something you should know actually. Tan 30 degrees is 1 over root 3 or root 3 over 3. Then tan 45 is equal to 1. Then tan 60 degrees is just root 3. Tan 0 is 0. Tan 90 is undefined. That's what we have. So that's how to solve for that very problem. Let's take a look at question 22. It says a straight line makes an angle of 30 degrees with a positive x-axis and cuts the y-axis at, okay, this is jamb 2001, number 26. So we're asked to solve this very problem. We're asked to find the equation of the line. I think this is going to take up 2 spaces, so let me wipe the other side. Okay, so let us start solving this very problem. Now remember that for you to find the equation of a line, you need 2 things. You need the gradient, you need one point to get the equation of any line. So first of all, this makes an angle of 30 degrees. And we know that gradient is equal to tan theta. So gradient is equal to, what would this guy become? What would this guy become? Tan, the angle is 30 degrees. So what is tan 30? I've just told you that tan 30 is 1 over root 3 or root 3 over 3. But I'm going to be using this, 1 over root 3. Now, the thing is this. I've solved maths a lot, and I can tell with the way things appear how to get my answer. Look, this is over root 3. And you can see that my root 3 in the option is actually with my y. It is with my y. Remember that the equation of a line, to find it, you say y minus y1 over x minus x1 is equal to gradient. Now, why did I use 1 over root 3? Because if I put 1 over root 3 here and I cross multiply, this will times the y part of it. So times the y part of it. Because right now, the options y, not the x is not the one having it. Because if I go and use root 3 over 3, you will see that using that one, it means the x will not be the one multiplying the root 3. You can see that, right? So I'm going to use this one. Please take note. It does not mean that if you use this, the answer will still not be correct. It will be correct too, but you now go through so many steps and procedure. Okay, this y minus y1 over x minus x1 equal to gradient. Now, we've gotten our gradient, but have we gotten our a point? Because we need a point. Now here's the thing. It says it cuts the y-axis at y equal to 5. Please, on the y-axis, take note that s is equal to what? 0. Invariably, on the x-axis, y is equal to 0. So it depends on which axis. Now, since they said the y-axis, on the y-axis, x is always 0 on the y-axis. Then they said the point where it cuts it is y equal to 5. So this is x1, y1. That's what it becomes. So that's easy. It's easy to find. So now let us use our equation, y minus y1 over x minus x1 equal to slope. So this is y minus y1 is 5 over x minus x1 is just 0. And then our slope is 1 over root 3. So this is y minus 5 over x minus 0 is just x equal to 1 over root 3. So let us cross multiply. This with times this. So that's root 3 brackets y minus 5 equal 1 with times x, or x with times 1. So that's 1 bracket x. So let us open up the bracket. So root 3 times y is root 3y. Root 3 times minus 5 is minus 5 root 3. Equal to 1 times x is just x. Now I can take this minus 5 root 3 to the other side. So this is root 3y equal x. If this minus 5 root 3 goes over, it's going to become plus 5 root 3. So that means our answer is B. So that's our answer. And that's how we solve problems like this. Let us move on to the next thing for the day. Perpendicular, and parallel lines. Now here's the thing. Two lines can either be perpendicular or parallel, even though we can have two lines that are just misbehaving anyhow. But there are two special types of lines, perpendicular and parallel lines. And right from when we were growing up, we've been taught that parallel lines can never meet. Yeah, they can never meet, but it all depends on the plane though. They can never meet. So they maintain the same distance away from each other. They maintain the same distance away from each other. So like I said, it depends on the plane, because right now, people have seen that it meets. So let's continue. So parallel lines, they don't meet, they maintain the same distance away from each other. Perpendicular lines, they meet, but they meet at 90 degrees. So for perpendicularity, the conditions for perpendicularity. For two lines to be perpendicular, the product of their gradients must equal to -1. M1, M2 is equal to -1. There's a way to derive this. Oh, remember that formula I gave that I said jamb? Oh, that I said jamb will not ask you. Tan theta equal M2 minus M1 over 1 plus M1, M2. Yeah, this is the formula to derive this. But since there's no need for me to derive it. So just know that if two lines are perpendicular, the product of their gradients must give you -1. Which means that M2, meaning one of the gradients, is always equal to -1 over M1. If you divide both sides by M1, this is what you're going to get. M2 is equal -1, then you divide by M1. Next, for parallel lines, for parallelism, if two lines have to be parallel, their gradients are always the same. These are the two conditions you have to note. These are the two conditions you would have to note very, very seriously. So when two lines are perpendicular, the product of their gradients is equal to -1. But I barely use this because it scatters my head. But this one is easy. The gradient of one is always the negative reciprocal of the other. Take note, what's the reciprocal? It means 1 over something. You flip that very thing, then you take the minus of it. I'm going to explain this with an example. But parallel lines are much more easier to deal with because their gradients would always be equal to each other. Remember, these two formulas are derived from this. So it's easy to get. I'm going to make a normal video sometime explaining every single thing better. Number 23. It says find the value of alpha if 2y minus alpha x plus 4 equal to 0 is perpendicular to the line y plus 1 over 4x minus 7 equal to 0. So these two lines are perpendicular. Yeah, they're perpendicular. Sorry, they're perpendicular. So we're asked to solve for alpha. So what do? We already know that if two lines are perpendicular, when the gradients multiply, you must always get -1. So here's what we're going to do. We're going to find the gradient of this line. This is the first line. Find the gradient of this other line. This is the second line. So let's get started. How do we find gradients? We must make y the subject. So for the first line, we have 2y minus alpha x plus 4 equal to 0. So first of all, let the 2y stay alone first. So this is 2y equal, if minus alpha x goes over, becomes alpha x. If plus 4 goes over, it becomes -4. For me to make my y stand alone, I need to divide every single thing by 2. So divide by 2. So this is 2y over 2 equal alpha x over 2 minus 4 over 2. So 2 we cancel at 2. So we have y equal alpha over 2x minus 4 over 2 is just 2. So that's what we have. Now what will become my gradient? Since this is the first line, I'll call this M1. It's alpha over 2 because gradient is that thing attached to x, so which is alpha over 2 in this case. And the next line is y plus 1 over 4x minus 7 equal to 0. Now, let us make y also stand alone. So I'm going to take every other term to the other side. So this is y equal plus 1 over 4x goes over becomes -1 over 4x. Minus 7 goes over becomes plus 7. So that's what we have. Now the next thing I'm going to do is to say m2 is equal -1 over 4. Because that's what's attached towards x. Now remember that these two must always multiply to give you -1. Because they are what? Perpendicular. So you say for perpendicular lines, M1, M2 is equal to -1. So what's M1? M1 is alpha over 2. Times what is M2? M2 is -1 over 4. Equal to -1. So let us times. Alpha times -1 is minus alpha. 2 times 4 is 8. Equal to what? -1. Now what do we do next? We can say this is -1 over 1. Then we cross multiply. So this will times this. So 1 times minus alpha, or minus alpha times 1 is minus alpha. Then 8 will times -1, so that's -8. If these two minuses cancel out, alpha is equal to 8. So that becomes our answer, which is C for Christ. That's what the answer is going to be. Let us take a look at the next question. So this question says, find the value of P if the line joining P, 4 and 6, minus 2 is perpendicular to another line joining 2, P and minus 1, 3. So here's what we're going to do. It's actually easy. Here's what we're going to do. We're going to find the individual gradients of both lines. There are two lines here. Take note. Anytime you see perpendicular and parallel, just know that two lines. So right now, let's find the gradient of this first line. The first line here. So let me say line 1. So line 1 is passing P, 4 and 6, minus 2. This is x1, y1. This is s2, y2. So m1, formula for m is y2 minus y1 over x2 minus x1. So what is y2? Y2 is minus 2 minus what is y1? Y1 is 4 divided by what is x2? X2 is 6 minus what is x1? X1 is p. So minus 2 minus 4 is minus 6 divided by 6 minus p. So this is the m1. Next, line 2. Line 2 is passing 2, p and minus 1, 3. So that's what I have. So again, let me name these points. So this is x1, y1, x2, y2. So m2, the formula for gradient is y2 minus y1 over x2 minus x1. So y2 is 3 minus y1 is p divided by x2 is minus 1 minus x1 is 2. So this becomes 3 minus p, that part stays the same. Minus 1 minus 2 is minus 3. So I'm going to leave every single thing like this. So there would have been a way to remove the minus, but let me leave it that way. Now, because the two lines are perpendicular, so for perpendicular lines, I will say that m1, m2 must equal to minus 1. It's a must. m1, m2 must equal to minus 1. So m1 is minus 6 over 6 minus p times m2 is 3 minus p over minus 3. And this will equal to minus 1. So to make life easy, let us kind of see if we can cancel out. So the minus here can take away this minus here. 3 here is 1. 3 into 6 is 2. So we're going to be left with 2 times this. So that's 2 brackets 3 minus p divided by 1 times this. So that's 1 bracket 6 minus p. And this will equal to minus 1. Beautiful, isn't it? So let us kind of expand here. 2 times 3 is 6 minus 6 times p is, 2 times p is 2p divided by 6 minus p. Please take note, do not be tempted. You cannot cancel this 6, so it's not possible. So leave it like that. Equal to minus 1 over 1. So let us cross multiply. So this will times this. So that means we're going to be having minus 1 times 6 minus p equal to 1 with times this. So that's 1 bracket 6 minus 2p. So let's expand. Minus 1 times 6 is minus 6. Minus 1 times minus p is plus, because we have two minuses. That's plus p equal to 1 times 6, that's 6. Then 1 times minus 2p is minus 2p. Okay, there are different ways to collect like terms here. Interesting. So how do we do this, and what would be the best way to collect like terms? Okay, I want all of the p to come here. So this is p, so I'm going to write p. If the minus 2p comes, it's going to become plus 2p. Equal to, this is 6, which has been here ever since. So this is 6. If this minus 6 comes here, it becomes plus 6. So that's what I have. Now p plus 2p, that's 3p. Equals 6 plus 6, that's 12. Now how would I get my value for p? Divide both sides by 3. So p is equal to 12 over 3, which is then 4. And my answer is A. So that becomes my answer. And that's how to solve that very problem. So let's go to the next one. So the next one is number 25. So number 25 says, what is the gradient what is the gradient of a line parallel to 3y minus 2x plus 8 equal to 0. Now, remember I told you that whenever you see a equation concerning parallel, perpendicular, they're talking about two lines. So let me assume that this is a line here. Then there's another line here. And these two lines are parallel to each other. Now, they give us the equation of only one of them. So they gave us the equation of this guy, 3y minus 2x plus 8 equal to 0. They gave us the equation for this guy. Then they said, find the equation of the line. That's another line that will be parallel to this very line. So they're not saying find the gradient of this very line. No, they're not talking about the gradient of this very line. They're saying the gradient of the other line. So how do we do that? We first of all have to find the gradient of this very line first. And then using the relationship we already know, we can then find the gradient of the line parallel to it. So how do we find gradient? We first have to make y the subject. So 3y minus 2x plus 8 is equal to 0. So let us make 3y stand alone first. If minus 2x goes away, it becomes 2x. If plus 8 goes away, it becomes minus 8. But the next thing for me to do is to divide every single thing by 3. So I'm going to say over 3, over 3, over 3. So this cancels this out. Y is equal 2 over 3x minus 8 over 3. So what will become our gradient? So M1 is equal to 2 over 3. So this is line 1. So that's 2 over 3. Now what will become M2? Now the beautiful thing about this very problem, this particular problem, is that the gradient, the second gradient, that's the gradient of the second line, line 2, is going to become the same with the first line. Do you know why it's going to become the same? Because the lines are what? Parallel. Remember I said for two lines to be parallel, their gradient must be the same. For two lines to be parallel, their gradient must be the same. Why if two lines are perpendicular, this will be the relationship. But if two lines are parallel, this is the relationship. So the gradients are going to be equal because they are what? They are parallel lines. Let us go on to the next question, number 26. So this question says, what is the gradient of the line perpendicular to 4y minus x plus 3? So this looks a little bit different because it's perpendicular, but it's still the same. So let's say we have perpendicular lines like this. Now we're given this first equation as 4y minus x plus 3 equal to 0. So that's the equation for this very line. But the equation does not say we should find a gradient of this very line. It's saying find a gradient of another line that's going to be perpendicular to it. So you have to be very, very careful. First of all, let us find the gradient of this line that we see here. So this line we see here is 4y minus x plus 3 equal to 0. So that's the line we see. Now, this is 4y. Can I move the minus x over? Yes, it's going to become ordinary x. And if the plus 3 comes over, it becomes minus 3. Now remember, to make y stand alone, you need to divide every single thing by 4. So divide by 4. So this is 4y divided by 4 equal x over 4 minus 3 over 4. So the 4 goes away. Now this is y equal, there's a 1 right here. This is 1 over 4x minus 3 over 4. So what will become my gradient? M1. Gradient becomes 1 over 4. So that is my slope. That's the gradient of the first line. So the gradient of this very line, M1, is 1 over 4. But for this very second line here, which they're actually asking us about, they're saying find the gradient of this very line, we need to use our relationship. But here's the beautiful thing about this. When it comes to problems like this, remember I said something. I don't actually use the M1, M2 equal to minus 1. It kind of stresses me out. Even for all of these problems, this problem here, I didn't want to use it actually, but I just had to do it because this very problem involved two P's, like the P is going to be on 2 lines. So that was why I just did it. Now, I want to solve this problem much more differently. For me to get M2, remember I said M2 is the negative reciprocal of M1. So first of all, let us think about this. If something is 1 over 4, what is its reciprocal? That's going to be 4 over 1. So that's basically 4. Reciprocal means flip the fraction. So if you have 1 over 4 and you flip it, that becomes 4 over 1. But remember there's a minus. There's a minus. So you put in minus. And that's your M2. So M2 is equal to minus 4. Or better still, you can use this formula to solve for M2. So let me use this formula for you. Let me use this formula. So we know that M1, M2 is equal to minus 1. M1 is 1 over 4. So this is 1 over 4, M2 equal to minus 1. I kind of have to cross multiply. So this is 1M2 all over 4 equal to minus 1 over 1. So when this times this, this is 1M2 times 1, which is M2. Then 4 times minus 1, that's minus 4. So it's still the same thing at the end of the day. So that's easy. You do not have to stress yourself. Just take the negative reciprocal of it. Here's question 27. It says, find the equation of a line parallel to y equal minus 4x plus 2 and passing through 12, 3. This becomes not difficult, just a little bit, advanced. So this time around, we'll have to find the equation of a line. So it's just like saying that these are two parallel lines, because I said the lines are parallel. These are two parallel lines, but the equation of the first one was giving us, the equation of the first one was giving us y equal minus 4x plus 2. They're asking us to now find the equation of the second one. That's what this equation is saying. Let us find the equation of the second one. So what do? It's very simple. The first thing we have to know is, let us find the gradient using this very guy. So y is equal minus 4x plus 2. So what will become m1? Because y is already the subject. Y is already the subject. So m1 is equal to minus 4. That's m1. However, what will become our m2? Because anytime we're talking about parallel or perpendicular lines, we're always going to be having two gradients. Always two gradients. So what will become m2? m2 is equal to minus 4 also. Because the gradients are always equal if the lines are what? Parallel. So the gradients are going to be minus 4, which is easy. Now how do we find the equation? Y minus y1 over x minus x1 is equal to gradient. So this is y minus, what is y1? Remember, this was the point we were given. This is x1, y1. So y1 is 3. Divided by x minus x1 is 2. And this will be equal to, what is our m? M is what? Minus 4. Take note, you are always going to be using this very guy. Always going to be using m2. Now, I can put over 1 here. So let's cross multiply. This will times this. So we'll have 1 brackets y minus 3 equal this will times this. So that's minus 4 brackets x minus 2. 1 times anything is that same thing. So this is y minus 3 equal minus 4 times x is minus 4x. Minus 4 times minus 2 is plus 8. You have to be very careful because minus times minus is plus. 4 times 2 is 8. Now, you can see that all of these options were made equal to 0. So you want to move everything over so that nothing will be left here. Then you can write your 0. So this is y minus 3. If minus 4x comes by, it becomes plus 4x. If plus 8 comes by, it becomes minus 8. And this will be equal to 0. So this is y plus 4x minus 3 minus 8 is minus 11. And this will equal to 0. So this right here is going to become our final answer, which is C. My God, C for Christ. That's what we have. So let's take a look at the next question, number 28. It says, find the equation of a line perpendicular to the line 2y equal 5x plus 4, which passes through 4, 2. Beautiful question. It is almost the same with this, but the difference is it is perpendicular. So first of all, what do? We find the gradient of this very line first. So we're going to say 2y is equal 5x plus 4. So let's divide every single thing by 2. So this becomes over 2, over 2, over 2. 2 we cancel out 2. So y is equal 5 over 2x plus 4 over 2 is just 2. Now, what is our gradient? M1, which is our gradient, M1, is going to become 5 over 2. So that's what M1 is going to be. This is M1. But remember, we must always find M2 because this equation involves two lines. I've already explained it before. This equation involves two lines. So what will become M2? Using the short approach I told you. First of all, what is the reciprocal of this? This will become 2 over 5. But it's always the negative word reciprocal, so there's a minus here. So the M2 is going to become minus 2 over 5. Check it out. If it times this very 2, guys, you are always going to be getting what? Minus 1. Please take note, the gradients are not equal because this equation says parallel. This equation says perpendicular. So there are two separate things. There are two separate what? Relations. Now, going with our formula, y minus y1 over x minus x1 is equal m. So that's what we have. And our point is 4, 2. So this is x1, y1. So let's proceed. So this is y minus y1 is 2 divided by x minus x1 is 4 equal to minus 2 over 5. Always use the m2. So that's what we have. Now let us cross multiply. So this will times this will times this. So 5 is going to times this. So this is 5 brackets x. No, that's a y. 5 brackets y minus 2 equal minus 2 times this. So that's minus 2 brackets x minus 4. So let's expand. 5 times y is 5y. 5 times this 2 here is 10. So that's a minus 10. Minus 2 times x is minus 2x. Minus 2 times minus 4 is plus 8. Now, every single thing from our options, they're always equal to 0. So we want to move everything on this side to the left-hand side so that here will be 0. So this will be 5y minus 10. If the minus 2x comes out, it's going to become plus 2x. If plus 8 comes out, it's going to become minus 8. And there'll be nothing left there. So that's why it's now 0. So this is 5y. This is plus 2x. So this is plus 2x. Minus 10 minus 8 altogether is minus 18. And that will be equal to 0. So that means our answer to this problem is B. So we've been able to solve for that question, and that's our answer. Now let us solve the next one. The next one is actually a 2013 question, 2013. And my God, that question is beautiful. So let's see question 29. So here's the question. We have to solve this very equation. It says, find the equation of the perpendicular bisector. Beautiful. Absolutely. Of the line joining P, bracket 2, comma, minus 4. So that means point P is at 2, comma, minus 3. Not minus 4, minus 3. Then we have Q at minus 5, comma, 1. So these are the options we have to solve this very problem. Find the equation of the perpendicular bisector of the line joining 2, comma, minus 3. So minus 5, comma 1. This is a very exceptional problem. It is truly exceptional. And here's why. You have to understand some basic things before you solve this very problem. It came out in 2013. You need to be very, very, you need to understand coordinate to solve this. So first of all, what is a bisector? So let me draw PQ here. So this is, let us imagine that this is PQ. So PQ is 2, comma, minus 3. That's for P. Then Q is minus 5, comma 1. That's for Q. So that's what we have. Now, this says that there's a bisector. A bisector, now it's this, split something into 2. So it divides this guy into 2. Let me put this guy here. So there's a line here. That's what I'm trying to say. Now, it's straight. Okay. Let's just assume that this is straight. So this line here is a bisector. It's dividing PQ into 2 places. The question is, what is the equation of this very line? Because this line is forming a 90 degree here, meaning it is perpendicular to it. It is perpendicular. So what is the equation of this very line? So let me say this is line AB. That's what I'm trying to ask us. Now the first thing is this. To find any equation, we need 2 things. We need a point and we need the gradient. So first of all, finding the point is very easy. Why is it very easy? This guy, it is split, so it's divided into 2 parts. So we need to find the midpoint. So the point is the midpoint. So the midpoint is the easy part for us to find. So let's find midpoint. So midpoint is going to become x1 plus x2 over 2, y1 plus y2 over 2. So since this is our point, we're going to say this x1, y1, this s2, y2. So what is x1? x1 is 2. Plus what is x2? x2 is minus 5 over 2. What is y1? y1 is minus 3. Plus what is y2? y2 is 1 divided by 2. So we're then going to be having 2 plus times minus is minus. So that's minus 5 over 2. Then we've got minus 3 plus 1 over 2. Now what is 2 minus 5? 2 minus 5 is minus 3. Then you put here over 2. Then what is minus 3 plus 1? Minus 3 plus 1 is minus 2 over 2. Now this part cannot cancel out, so leave it like this. But minus 2 over 2 can cancel out. So we're going to be having minus 3 over 2, comma, minus 1. Beautiful indeed. Now we've been able to get the midpoint. So we now have a point of this very line. We have a point. And that point is minus 3 over 2, comma, minus 1. So that's a point. But we still need to find the gradient. Now, how do we find the gradient? First of all, what is the gradient of PQ? If you can find the gradient of PQ, you can then find the gradient of AB. So let us find the gradient of PQ. Let me say MPQ. So gradient is y2 minus y1 over x2 minus x1. So what is y2? y2 is 1 minus what is y1? y1 is minus 3. So put a bracket minus 3. What is x2? x2 is minus 5 minus what is x1? x1 is equal to 2. So this is 1. Minus times minus is plus. And then we have minus 5 minus 2. So what is 1 plus 3? 1 plus 3 is 4. And then what's minus 5 minus 2? That's minus 7. So that's what we have. But remember, this is the gradient for what? PQ. We're looking for the gradient of what? AB. If these two lines are perpendicular, what did I tell you? I said M1, M2 is equal to minus 1. So for us to get the gradient of the second line we need here is the line AB. That is the second line we need here. But I don't want to use this formula. Remember that the second gradient, which is gradient of AB, is the negative reciprocal of this very guy. So let us reciprocate this. The 7 goes up, so this is minus 7. The 4 comes down, so that's 4. But they say it is the negative reciprocal. So since there's already a minus, there's a minus here already. So this becomes plus, because minus times minus is plus. So the gradient of AB is 7 over 4. Now, if you don't understand this, let me solve it here. M1, the first gradient that we solved was 4 over minus 7. So this is 4 over minus 7. Then we have M2 equals to minus 1. Now I can put over 1 here and cross multiply. So this will times this will times this. 4M2 times 1 is 4M2. Minus 7 times minus 1 is plus 7. Because minus times minus is plus, 7 times 1 is 7. Now how do I get M2? I basically have to divide both sides by 4. So this is 7 over 4, which is still the same thing. So basically, I don't just like doing this. It takes my time. So I just flip it and multiply by minus. So that's my MAB. And right now, I have everything I need. I have a point and I have a gradient. So let me now find the equation of the line. So to find the equation of a line, y minus y1 over x minus x1 is equal to gradient. So this is y minus, what is y1? Remember that the new points that I am using, this is the point I'm using. So this is x1, y1 for this very line. So y1 is minus 1, so put a bracket there. And this is x minus, x1 is minus 3 over 2. Put a bracket here also. The gradient is 7 over 4. There are so many fractions. So this is y minus times minus is plus, divided by x, minus times minus again is plus, equal to 7 over 4. There are so many brackets here. So many. So here's what I'm going to do. Don't worry, I can manipulate so many things. So here's what I'm going to do. Do this part first. This is over 2. This over 2. So I want to times here by 2 over 2. So that this fraction will go away. So 2 times y is 2y. Then 2 times 1 is 2. So that's 2y plus 2. Then 2 times x is 2x plus 2 times 3 over 2. Here's it. 2 times 3 over 2. These two can cancel out this very 2. So that's plus 3. And this would equal to 7 over 4. Yes, I can do that. And there's no fraction anymore. I can do that. That's exceptionally beautiful. The next thing that I'm going to do is to cross multiply. So this multiplies this. So that's 4 brackets 2y plus 2 equals 7 we times this. So that's 7 bracket 2x plus 3. So 4 times 2y, what's that going to give to us? 8y. Then 4 times 2 is 8. equal 7 times 2x. That's going to give us 14x. 7 times 3 is going to give us 21. Now what I'm going to do next is, if I look at every single thing in the option, it is equal to 0. So I want to make every single thing there equal to 0. So this is 8y plus 8. If 14x comes over, it becomes minus 14x. Plus 21 comes over, becomes minus 21, equal to 0. So this is 8y minus 14x. This is 8, and this is minus 21. They are like terms. So 8 minus 21 is minus 13, and that will be equal to 0, leaving us with our answer as A. So that's our answer, and that's actually very, very simple for us to solve. It's easy. So that's what we do. Next, the next question, which I kind of think is the last question, number 30. Number 30, is this enough space? Let me just manage this. Find the equation of the line with x-intercepts 3 and y-intercept minus 5. Now here's the thing. There was a time JAMB gave this very equation. I am trying to remember what year. If it's not 2014, they gave it as a graph actually, as a graph. I think I'm going to remember it sometime. So it was kind of like this. That's not fine. So they gave it like this. And they said, find the equation of the line. They put a point here, put lines here, and stuff like that. Please take notes. I'm going to be making a much more, I think, a one-by-one video to solve different problems. So you might see a question where I would then treat graph, but I don't think they're going to give you that one in the exam. So what you just do is this. When you encounter this very problem, get this very point here, get this very point, get this very point, and you can solve for the equation of a line easily. So at this very point, remember, this is the y-axis. On the y-axis, s is always 0. So in this case that says that the y-intercept is minus 5. So this is 0, minus 5. That's the meaning. That's what it means. Because on the y-axis, s will be 0. Then on the x-axis, y will be 0. Let me say that again. On the y-axis, s will be 0. Then on the x-axis, y will be 0. Remember I said there's a way to find the equation of a line using the intercept form. But since I don't want to introduce something new to you so it doesn't become a bulky thing for you to bear, let us use our normal one. X-intercept is at 3. So on the x-intercept, x is 3, y will be 0 because it is the x-intercept. Then they said y-intercept. On the y-intercept, x will be 0, y is equal to minus 5. So these are your 2 points. So that's how you solve this very problem. Be very, very careful. So this is x1, y1. This s2, y2. So to find the equation of a line, y minus y1 over x minus x1 is equal y2 minus y1 over x2 minus x1. So let us get started. This is y minus, what is y1? y1 is 0. So this is 0 divided by x minus, what is x1? x1 is 3. So that's what we have, 3 equal y2 is minus 5. y2 is minus 5. Minus what is y1? 0. What is x2? 0. Minus what is x1? 3. I've basically just done everything there. So this is y minus 0 is still y. So this is y divided by x minus 3. What is minus 5 minus 0? That's minus 5. What is 0 minus 3? That's minus 3. So these two minuses will take care of themselves. So this is y divided by x minus 3 equal to 5 over 3. Next thing I'll do is to cross multiply. So this will times this. So y times 3 will give me 3y equal 5 will times this. So that's 5 brackets x minus 3. So next, this will be 3y equal 5 times x is 5x. 5 times minus 3 is minus 15. Now I want to move everything over to the other side. So this becomes 3y minus 5x. If this minus 15 comes over, it will become plus 15. And this will now be equal to 0. So that's going to be how we solve this very problem. This will be the end of this very video. Thank you very much for staying up to this portion. And if you've not yet hit the subscribe button, please do so. I'll see you guys in the next video. Bye for now.